Hi, this is a review of the second half of Precalculus Chapter 2, and so this is going to cover a lot of things like the Fundamental Theorem of Algebra, solving and factoring polynomials, and then everything that could possibly be related to graphing rational functions. So let's get started. This first problem on our review is supposed to be super easy. If a polynomial has a degree of 6, that means that there should be 6 answers, and they're telling us 1, 2, 3, 4 answers, which means we are missing 2. And so there has to be some way for us to know what those other 2 are, and they have to do with imaginary roots and irrational roots. These roots always come in pairs. So if you know that 5i is an answer, you also know that negative 5i is an answer. If you know that negative square root of 7 is an answer, you know that positive square root of 7 is an answer. Because if I tried to put these together and multiply them out to recreate the polynomial that we started with, if I don't include negative 5i and square root of 7, then I'll end up with these really gross imaginary and irrational coefficients. And the irrational coefficients may not be that big a deal, but we don't typically we would never want to see an imaginary coefficient. That would be crazy. So that's what we have to do, is just say, all right, whatever, if I have an I or a square root, I have to change the sign, and those are also zeros. On this one, a rectangular prism has a volume of, and they give us a polynomial, and a height of x minus 3. Find the length and width of the prism. So this has to do with the fact that the volume of a rectangular prism, which is a fancy word for a box, is length times width times height. And so if we know the volume and the height, we can divide the height over and figure out what the length times the width has to be. So if I'm going to do 2x squared minus 7x squared plus 2x plus 3 divided by x minus 3, I can use long division or synthetic division. The way you know that you can use synthetic division is if there is not a number in front of x. And since there's not, I just set this equal to 0 and I solve for that to figure out the number to put over on the side, which is positive 3. I take the numbers from in front of these x's and then the last number and write them down. And then synthetic division is pretty easy and pretty quick. You just have to remember that the first number just drops down, and then you go back and forth multiplying and adding. Multiply 3 times 2 and get 6. Add negative 7 plus 6 and get negative 1. 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. 3 times negative 1 is negative 3. 3 minus 3 is 0. So what we get is that our length times our width is 2x squared minus x minus 1. And so to figure out what our length and our width actually are, we would need to go ahead and factor this into 2 parentheses. There are lots of ways to do this. One way is to just guess and check, which in this case wouldn't be too difficult because 2x squared has to split up into 2x and x. Negative 1 has to split up into a positive 1 and a negative 1. So we really just need to figure out which way should be positive and which way would be negative by thinking about foiling. So should I do 2x minus 1x, or should I do 1x minus 2x? The second one of those is what I want to do. So this is negative and this is positive. The other way to do it, where we're not actually guessing and checking, or one way that we can do it without doing guess and check, is called slide and divide. And so when you slide and divide, you slide the 2 over to the negative 1 and multiply. So you say x squared minus x minus 2. You split that up into 2 parentheses, like with normal factoring, where you say what multiplies to get negative 2 and adds to get negative 1, which is negative 2 and positive 1. And then you finish by dividing by 2. And the problem with slide and divide is it's really easy to forget the last step where you have to divide so that you get x minus 1. When it doesn't actually divide like this 1/2, you move the 2 in front of the x. And so this is 2x plus 1. That's like a shortcut kind of, in a way, like sometimes it's really hard to guess and check because there's a lot of different numbers that you could use and it can be hard to figure out which ones to use. And so slide and divide gets around that, but you have to remember that last step where you divide and then move whatever doesn't divide in front of your x. What we know now, we can't necessarily tell which of these is the length and which of these is the width, but we can know that the length and the width in general are these two things, 2x plus 1 and x minus 1. We don't know which one is which for sure, although I would say 2x plus 1 would have to be the length and x minus 1 would have to be the width, since whatever you put in for x, this is going to be bigger than this, and length is normally bigger than width. But that's kind of a side note. So number 3. So I realize this says number 4, but on our review it's number 3 because I accidentally switched these out of order, which is totally fine. But synthetic division is like what we just did. So we take b plus 2 and set it equal to 0 and solve, and that tells us to put -2 over here. Then we put 1, -7, -17, and 5. It's super important that if it's missing something from standard form, like if this wasn't here, we'd have to put a 0 in its place. And it's super, super important that you do that and pay attention for that. So we're going to do what we did on the last problem. Drop the first number, multiply, add, multiply, add, multiply, add. Then we're going to write out our answer. So I didn't say this on the last one. The way this works is if this is cubed, we're going to start with b squared. We always start 1 power less. So we do b squared minus 9b plus 1 plus our remainder. It's plus because our remainder is positive, and we put 3 over what we were dividing by, which was b plus 2. And that's our answer. Now we're going to do long division. So long division will always work, whereas synthetic division is a shortcut that only works some of the time. And so our problem here is, even if we wanted to try to, be crafty and use synthetic division, even though it tells us to use long division, we would get the wrong answer because there's a number in front of n, and so it makes synthetic division not work, or at least not work as well. And so what we're going to have to do is long division. So we put 4n plus 5, and then we put 4n cubed minus 15n squared minus 29n plus 3. Again, we need these to be in order, like standard form. If there is something missing, we put plus 0 n squared or plus 0 n or whatever's missing, so that we can keep track of all of our terms. And then the process goes like this. You say, what do I multiply 4n by to get 4n cubed? And we write it up here at the top where our answer is. So to get from 4n to 4n cubed, you have to use n squared. And so I like to write it above the other n squared so I can keep track. I know that I'm going to need an n and a number, and then I might have a remainder at the end because I put this in above the n squared. So after I figure out what goes up here, I multiply both of these by n squared and write it underneath. So I write 4n cubed plus 5n squared. But what we want to do is subtract both of these things because we want them to cancel. We want these two things to cancel out. 4n cubed minus 4n cubed cancels, and then that negative makes this be minus 5n squared. So I'm going to do negative 15n squared minus 5n squared and get negative 20n squared. What we typically, the easiest mistake to make is to not change that sign, and that would have given us negative 10n squared, which 4 doesn't go into. And so if that's what you're facing, then you want to try it with the opposite sign and see if that gives you something that works out. And if it does, then that's probably what your issue was. You drop the next term, negative 29n, and then we start this process over because we say, what do I multiply 4n by to get negative 20n squared? So to get that, I need negative 5n, because I need it to be negative. I need to times it by 5, but I also need another n. So I times both of these now by negative 5n, which gives me negative 20n squared minus 25n. But I'm going to subtract these. And so whenever I subtract these, that changes both of those to positives, because a negative, change, or whatever you learned in like 8th grade or 9th grade or 7th grade or whenever, those both become pluses so that this cancels. Negative 29n plus 25n gives you negative 4n. Again, if you don't change the sign there, you're going to get something that won't work out on the next step. So if that's something that happens to you, just try changing the sign and see if that works out better. All right, what do I multiply 4n by to get negative 4n? Well, you might be like, well, nothing, it's already what I need, but I do need to multiply it by a negative, so I'm going to say negative 1. Even if these were the exact same, I'd still have to put a plus 1 here to show that I needed something there. So I multiply both of them by negative 1 and get negative 4n minus 5. I'm going to subtract those, which changes both of these to positives, so that I get this to cancel, and 3 plus 5 is 8. Since I don't have anything else to drop down, that's my remainder. Since it's a positive 8, I put plus 8 over 4n plus 5. If it had been a negative 8, I'd put minus and then 8 over 4n plus 5. Also, the 8 and the 4 can't simplify. The only way I could simplify on this last fraction is if everything was divisible. Like if this was 4n plus 6 on the bottom and an 8 on top, I could divide all of those by 2, but I can't because the 5 isn't divisible by 2. Write the polynomial in factored form. One factor has been given. So this is going to be, there's just a lot of synthetic division on this review. And so if they tell me that x plus 3 is a factor, then what I'm going to do is synthetic division by saying this is x equals negative 3. So that's what goes over here in my box. I put 1, 8, 16, 8, and 15, and then go for it. The reason I'm going to do synthetic division is because they told me an answer, basically, and that's going to help me make my polynomial smaller, because it's going to take me from x to the 4th with 5 terms, which I can't factor, to an x cubed with 4 terms, which hopefully I can factor. So I do synthetic division. And it has to work out so that there's no remainder. If it doesn't, you did something wrong. It tells us this is a factor, which means there shouldn't be a remainder. And so I write my answer as x cubed, since it started off x to the 4th and we divided. It's x cubed plus 5x squared plus x plus 5. And so now my goal is to try to factor this into 2 parentheses by grouping, because if I have 4 terms, it's factoring by grouping or I can't factor. So I look at the first 2 terms and say they both have an x squared in common. And I take out the x squared and get x plus 5 whenever I take it out of both of those terms. Then I look at the last 2 terms and see what they have in common. They don't have anything in common, so I'm going to have to put plus 1 and then x plus 5 in parentheses, because I want these 2 things to match, and now they do. I get x plus 5, and then next to that I'm going to write what's left over, x squared and the plus 1, and then next to that I'm going to write what I started out with, which was x plus 3, and I'm going to look at this and say, okay, is there anything else I can do? Now some of us are going to look at this middle one and say, well, I can factor that, right, into like x plus 1 or something like that, and I can't. If this was x squared minus 1, that factors into x plus 1, x minus 1. But if it's a plus sign in the middle, it can't be factored, because if I try to solve this, I end up with imaginary numbers. Like if you set it equal to 0, this part in the middle, you get positive and negative I, and because that's what you get, that means that you can't actually factor it. So this is my answer right here. Find all the roots. One root has been given. So this is a very similar problem. The other problem we stopped when we knew what the factors were, but this one we want to find the roots, which means the same as zeros or solutions or x-intercepts. All of these words mean the same thing, and it means that I'm going to go a step farther than what I did on the last problem, and I'm going to set things equal to 0 and solve. One thing to note is they're telling me that -5 is what x equals, which means that I don't need to change the sign when I do synthetic division. So I've got 2, 15, 28, 15, and then there's not a number at the end, so I'm going to put a 0. The 0 is not because that's 0, the 0 is because it doesn't have like a +1 or a +5 or anything at the end. So I'm going to drop the first thing, and then multiply, then add, then multiply, then add, then multiply. And so in actuality, if the 0 is at the end, it may not matter. Like, you might still be able to figure this out if you didn't put that 0 at the end, but it's better to be safe than sorry. So since this started off as x to the 4th, we're going to have 2x cubed plus 5x squared plus 3x. And so what we want to do is we want to factor this so that we can set our parts equal to 0 and solve. Well, all of these have an x in common, so we can say, let me take out the x and get 2x squared plus 5x plus 3. And so that x being taken out means that x equals 0 is an answer. So we know x equals -5 is an answer because they told us. We know x equals 0 is an answer. We also know that since this started off as x to the 4th, there should be 4 answers. So if I keep going, I'm going to factor this into 2 parentheses. Now, there's 2 main ways to do that. One is to just guess and check. And so to guess and check, you say, how would I split up 2x squared? I'd split it up into 2x and x. You'd split up the 3 into 3 and 1, but you have to figure out where to put the 3 and the 1 so that if you were to FOIL the outer and inner terms, so these 2 terms and these 2 terms added together have to give us 5. And so the way that's going to work is if this is a 3 to get 3x, and this is a 1 so that we get 2x, and we add those together and get 5x. That is kind of tricky, and so the other way of doing that is to go ahead and slide and divide. So I slide the 2 over here, and I say that's x squared plus 5x plus 6. And then I say, all right, well, what multiplies to get 6 and adds to get 5? Which you have to be careful about, because 6 and 1, it would only work if this was a -6. Since it's a +6, we need to pick 2 and 3. And the second part of slide and divide is where you divide by what you slid by, which was 2, which makes this x plus 1 and 2x plus 3. Because if it doesn't divide, we simplify if we can, but we move the bottom number in front of x. So either way we went about this, we got the same thing. Now we're going to set it equal to 0 and solve. So when x plus 1 equals 0, that means that x equals -1. And then when 2x plus 3 equals 0, that means that x equals -3/2, because you subtract the 3 and then divide by 2 and get -3/2. So that gives me my other 2 answers for a total of 4, so that I'm done with that problem. On 7, find all the zeros algebraically. Write your answer as fractions and square roots, not as decimal. And really that goes for the 2 problems that we did before this. I'm not wanting you to try to graph this, and graphing it actually only gets you so far, but we specifically on this one want to look at this and try to do this without our graphing calculator. That's what algebraically means, is don't graph it. And so if you have 4 terms and you're trying to do something algebraic, factoring by grouping is really your only option. So look at these first 2 terms and say, well, they have a 4x squared in common that I can take out and be left with x plus 2. The last 2 have a -5 in common that I can take out and get x plus 2. So that means this is x plus 2 times 4x squared minus 5 And so we're going to set this equal to 0 and solve, which means that I take x plus 2 and set it equal to 0, and then I take 4x squared minus 5 and set it equal to 0. And between these two things, I should end up with 3 answers. One of them is -2. The other one, I add 5 to both sides and get 4x squared equals 5. I divide by 4 and get x squared equals 5/4. And then here's where it gets tricky. You square root both sides, which makes this be x equals positive and negative, because you square rooted, and that means we need 2 answers. You can't take the square root of 5, but you can take the square root of 2. So you can leave it as plus and minus square root of 5 over 2. Number 8, the instructions are not on here, so it says write a polynomial function of least degree with integral coefficients that has the given zeros. So we want to change the signs and put these into parentheses, because it's like they're giving us the answers and they want us to write the polynomial that goes with it. And so I'm going to multiply out these parentheses, starting with 2 of them and then including the other one once I'm done. So if I FOIL this out, I get x squared plus 3x plus 4x plus 12. And in the middle, that adds together to get 7x. And now that I've done that, I'm going to take the x minus 5 and multiply it through. So when we do 3 terms and 2 terms together, we take one of our terms and multiply everything by it. Then we take the next one, multiply everything by it, and then add our like terms. So this is x cubed plus 7x squared plus 12x. And then you do -5 times each of these. So -5x squared minus 35x minus 60, and then add your like terms. So x cubed, 7x squared and -5x squared is 2x squared. 12x and -35x is -23x. And then the minus 60 goes at the end, and that's our polynomial. Now this one's trickier, because it's almost like it's a trick question. So on number 1, we said that if there's an I, then there has to be another I also. So they told us -3i. We have to know that that means that +3i is also a 0. If you just try to do x plus 3 and x plus 3i together, you're going to get something that seems pretty unpleasant. And so you have to remember that x minus 3i also has to be there. You want to multiply these two together first, so that you can get rid of the i's, and then you'll multiply by the x plus 3. So this is x times x, which is x squared. The outer terms and the inner terms are going to be the same with opposite signs. There's -3ix and +3ix, and so those cancel out, and then we do 3i times -3i and get -9i squared. -9i squared, you take the I squared and make it turn into a -1, so that that's really x squared plus 9. And now we can finish by foiling these together. And if you actually FOIL but do inner and then outer, it'll be in standard form. So it's x cubed, and then 3x squared, and then 9x, and then 27. And that's your answer. (10 through 12, and then 13 is also related to that. 10 through 12 are asking you to identify the horizontal asymptote of each. Technically, you can graph these and use the picture of the graph to help you with this, but if you don't understand the math behind it, you're probably not going to be able to read the graph very well anyway. For instance, on this first one, since our biggest exponent on the top and the bottom is x squared, that means that what we have will cancel, and we'll do 1 over -2 and get y equals -1/2. And that may be hard to tell from the graph. Like if you were looking at the graph, you might guess that it's 0 or -1, but the chances of you guessing it's -1/2 are not super good. So keep that in mind, that it's not just about being able to graph it and using that. You also have to be able to look at the equation and say, okay, what's the equation actually telling me? Like in this one, there's not any x's on top and there are x's on bottom, which makes this be y equals 0. On 12, there's an x cubed on top and an x squared. So there's more x's on the top, which makes there not be a horizontal asymptote at all. What happens is if there's not a horizontal asymptote, you can divide these two things and get a slant asymptote. And so on 13, when it asks you which problem has a slant asymptote, you would say number 12, because the only time that happens is if there's not a horizontal asymptote. We would never have a slant asymptote when we also had a horizontal asymptote, like on 10 and 11. So that's supposed to be like not a lot of work and fairly straightforward, but if you don't understand horizontal asymptotes, that's like 4 questions you would have just gotten wrong, and that's like a lot. So you want to know how to do those for sure. Identify the holes in vertical asymptotes. We need to factor the top and bottom for this because holes happen where we cancel and vertical asymptotes happen on the bottom with things that we, like if we haven't canceled something out. Now 14 is some tricky factoring. On the top we need to take out an x first and get x squared minus 5x plus 6. And then we need to factor again because we can split up x squared minus 5x plus 6 into x minus 3 and x minus 2. Because you want what multiplies to get positive 6 that adds to get negative 5. On the bottom, we can take out a negative 4 and get x squared minus 4, but then x squared minus 4 splits up into x plus 2 and x minus 2. So we look at the top and the bottom and we see if there's anything in common. The x minus 2's are in common and will cancel, and so that means there is a hole where x minus 2 equals 0. So there is a hole at x equals 2. The vertical asymptotes happen where we didn't cancel, so at x plus 2 equals 0. So you set x plus 2 equal to 0 and solve and get a negative 2, and so that's where your vertical asymptote is. The negative 4 on the outside doesn't do anything to our vertical asymptote or our holes, because if I set it equal to 0, it doesn't actually solve for x, because it's just a number. On this next one, the top is just x plus 3. If I factor the bottom, I get x plus 2 and x minus 1. So nothing cancels, which means there are no holes, and both of the things on the bottom are our vertical asymptotes. So that's x equals negative 2 and positive 1. You could also graph these and use that to help you. You'll be able to see the vertical asymptotes on the graph, but the holes, if there are any, will only show up as errors on your table. So you'd have to go and look at your table and find your errors. Like on 14, there's an error at negative 2 and positive 2, but on your graph, there's only a vertical asymptote over here at negative 2 and not at positive 2. I was going to try to draw a graph of that, but never mind. Forget I started that. 16. So finding the zeros of rational functions is where you set the top equal to 0. But in order for us to do that, we need to factor the top and the bottom, because if I factor and have something in common on the top and the bottom, that's a whole, not a 0. So let's see if that happens. What multiplies to get 6 and adds to get 5 would be 3 and 2. On bottom, what we split up x squared minus 4 into x plus 2 and x minus 2. The idea there is that you want to know what multiplies to get negative 4 that cancels out, because there's not a middle term. So that has to be a positive 2 and a negative 2. So we do have something in common that cancels. There's a hole at negative 2 and an x-intercept at x plus 3 equals 0, which means there is an x-intercept at x equals negative 3. So if you put -3 and -2, you'd be partially right, but it doesn't actually go through the x-axis at -2, so you wouldn't want to put that as an answer. On 17, even if we factor the bottom, and you can if you want to, like, it's still not going to cancel out with what's on top, because it's going to be x plus or minus something, x plus 3 and x minus 2, and that can't cancel out with the 4x on top. So we just need to set the top equal to 0. And so if 4x equals 0, you divide both sides by 4 and get x equals 0 as your answer. And on both of these, again, we could graph and check out our graph, and as long as we know how to do that, like, we can look at the graph and know what our answers would be, and we can use that to help us. But again, you have to have like practiced doing that, or you won't really know what to look for. Identify the domain of each. So the domain of our function has to do with where the bottom of our function equals 0. So if x minus 3 equals 0, that means x equals 3. And so for our domain, what we care about is that x can't be 3. Like, if I am trying to plug numbers into this function, if I plug in 3, I get a 0 on bottom, and that gives me an error or an undefined spot. And so if I want to write the domain in interval notation, I say that this is -infinity, comma 3, and then 3, comma infinity. And what it does is the fact that these are both parentheses means that we're saying that I can plug in everything up to 3 and everything past 3, but I can't plug in 3. Over on 19, we want to set the bottom equal to 0, and so we're going to have to factor, because to solve x squared plus x, I mean, you can use the quadratic formula, but that's a lot more work than you need to use, because I can take an x out of both of these and get x times x plus 1, set both of those equal to 0, so I get x equals 0 and x equals -1, which means that on my interval notation, there's going to be 2 places that I have to break up. So I'm going to start from -infinity, and I need to write whichever one of these is to the left first, which would be -1. And then I can go from -1 to 0, and then I can go from 0 to infinity, and that is my domain. It didn't matter, like, I didn't have to factor the top on 19, because even if something canceled out, that's a whole, but that still affects my domain, because it's still going to give me errors on my table of values in my graph. So if you were wondering about that, that's why I didn't factor the top, because even if it had canceled out, it's still a problem for my domain. 20, 21, and 22 ask us to identify the holes, vertical asymptotes, zeros, and horizontal asymptotes. And if the graph has a slant asymptote, find it, and then we're going to sketch the graph. And so all those things it's asking us to find are things that we need to find to graph this anyway. And so I'm just going to write my list of things that I'm finding over here. Horizontal asymptote, and this is the order I find them in personally. Horizontal asymptote, holes, vertical asymptote, and zeros, which is the same as x-intercepts. So to start off with horizontal asymptotes, you look at the biggest x on top and the biggest x on bottom as far as exponents go, and you say which has a bigger exponent, the top or the bottom. If the bottom has a bigger exponent, like in this case, it's y equals 0 for our horizontal asymptote. After that, everything else we need to find requires us to factor this. So on top we say these both have a 3 in common, which leaves us with x minus 4. On the bottom, we split this up into 2 parentheses where we say what multiplies to get -12 and adds to get -1, which is -4 and +3. We look at this, and for our holes, we want to know is if something cancels. X minus 4 cancels on top and bottom. So there is a hole where x minus 4 equals 0, which is at x equals 4. Then we ignore that for the rest of what we're finding. Our vertical asymptote is where the bottom equals 0. So where does x plus 3 equal 0? It equals it at x equals -3. Our x-intercept is where the top equals 0. Since 3 can't equal 0, there are no x-intercepts. If I want to graph this, I might want to put it in my calculator at some point. I probably will want to put it in my calculator at some point. But for now, I can draw my horizontal asymptote at y equals 0. I can draw my vertical asymptote at -3. And after that, honestly, you'd either have to plug in values for x to figure out some points to plot, or we'd have to look at a graph of this. So put it in your calculator into y equals. I have it graphed right here. So this is what our graph looks like. And so what that tells me is that I need to draw my graph at the top right and the bottom left. This is kind of zoomed out. There, that's a little better. I can, if you're on like your TI calculator, you can go to table of values and find some points to plot. Here I can find, looks like 0, 1 is a good point, and I think -2 might be, yeah, -2, 3 is a good point. So let me go put those on there before I forget. 0, 1, and -2, 3. And so there should be some points over here that are similar to that I can find, like -6, -1, and -4, -3, -6, -1, -4, -3, -6, -1, -4, -3. And so it's easier on your table of values because you're just looking for things that aren't fractions or decimals, basically. And so I want this graph to go toward my asymptotes either direction, but through the points that I just picked. And once I am done drawing this, then we'll talk about how to put the hole on here. Because this graph has a hole at x equals 4, and so what you do is after you're done graphing, go to 4, erase what you've got, and then you just put an open circle there at 4. I kind of made that a really big open circle on accident. It's just an open circle at 4 shows that there is a hole at 4. 21, the problem that I had on the review I didn't like, so I changed it, and so this looks terrible. The problem is x squared plus 5x plus 6 over x plus 1. We're doing the same thing as on 20. We want to figure out horizontal asymptote, holes, vertical asymptote, and zeros, which are also known as x-intercepts. So the first thing we do for horizontal asymptote is we say, well, x squared over x, that means there's no horizontal asymptote, which is actually unfortunate because that means we're going to have to divide to figure out what our slant asymptote is. So let's use synthetic division. This is -1, and then 1, 5, and 6. And I want to do synthetic division. So I drop the 1, multiply, add, multiply, add. When we're doing slant asymptotes, we ignore the remainder and we just write this as x plus 4 and it's y equals. It's a line. Y equals 1x plus 4. The way I graph that is the 4 is my y-intercept, the 1 is my slope, so I'm going up 1 over 1. And so here is my dotted line for my slant asymptote. If you're not sure, like if you can get that, but you don't know how to graph it, just plug it into y equals on your calculator and use your table of values to plot some points. Now I need to go through and find the rest of these things. Like I can factor the top and get x plus 3, x plus 2. Nothing cancels, so there's no holes. My vertical asymptote is where the bottom equals 0, which is at x equals -1. And then where the top equals 0 is my x-intercepts, so that's -3 and -2. So if I put those on my graph, I have a vertical asymptote at x equals -1. And my graph is going to go through -3 and -2. So if you know what this looks like, it's going to go down towards this asymptote. It's probably going to curve up a little and then come back down towards this one, and then it's going to end up being just up here as well. Like they're either in the little parts of your graph or they're on the big parts of your graph. So if I go and actually look at a real graph of this to make sure that I'm right, bam, that is at least kind of what my graph looks like. So there you go. Next, we want to find all these things again. Horizontal, holes, vertical asymptote, and x-intercept. So my horizontal asymptote, I compare my x's on top and bottom. They're both x squared, so it's like I'm ignoring everything else and saying, well, what's 2x squared over x squared, which is a 2. So this is at y equals 2. I'm going to factor the top and the bottom. The top I can take out a 2. The bottom I can take out an x and get x plus 3. Although on top I'm not quite done because I can actually factor that into x plus 1 and x minus 1. And so nothing cancels, there's no holes, but there are two vertical asymptotes, one at 0 and one at -3, because I just set each of these equal to 0 on bottom. On top, I set the x plus 1 and the x minus 1 equal to 0, and that tells me that I have an intercept at -1 and at +1. So if we put this on our graph, we got a horizontal line at 2, a vertical line at 0, and at -3. And then we are going through the x-axis at -1 and +1. This actually, I don't know, I would want personally to look at a graph of this before I started drawing it to be sure I knew what was happening. And so this is a pretty weird looking graph, if I'm being perfectly honest, but if you're looking at this and your table of values to find some points, and then coming back here and trying to draw it, it goes closer to this asymptote and then goes this way, and then it's going up towards this one and down towards this one, and then it's up here. What should happen in general is, like, on either side of a vertical asymptote, they should be at opposite ends. Like on the left side of this one, it's on top, right side it's on bottom. Left side of this one, it's at the top, right side it's at the bottom. Very rarely will they both go towards the same thing. It can happen, it just doesn't really happen a lot. 23. Which of the following functions has a vertical asymptote but no horizontal asymptote? Well, all of these have vertical asymptotes because that's where you set the bottom equal to 0 and solve, and on all 4 of these we would get an answer. So the question is, which of these wouldn't have a horizontal asymptote? This one has a horizontal asymptote of 1. This one has one of 1/5. This one has one of 0. This doesn't have one because there's more x's on top than there are on bottom. So our answer is D. You could graph all of these and check to see which one doesn't have a horizontal asymptote. So x squared over x minus 2 has to be one of those weird looking graphs that, like, you know, has the off-kilter thing instead of looking, well, that still doesn't look very good, you know, but like that, you know what, never mind. Just graph them and see, or whatever. 24, write a rational function that has a hole but no vertical asymptotes. So in order for something to have a hole, it has to have factors that cancel out. In order for it to have a vertical asymptote, it would have to have something else on the bottom also. And so so I can just actually leave it like this. As long as I have two things that would cancel, then I'm good to go. If I include any other x on the bottom of this, then I would be wrong, because anything else with an x on the bottom of this is going to make me have a vertical asymptote. So there you go. 25 is a problem from our last test that was most missed, and so in order for us to roll back our test grades, we have to be able to do this. problem, and so that we can hopefully get a higher grade. In order for us to write the vertex form of an equation, we need to know what vertex form looks like. It's y equals a times x minus h squared plus k. Our vertex is h and k, and it passes through x and y. And so we plug all of those numbers in. Y is negative 13. We don't know what a is, and that's what we're going to try to find. X is 13. H is 10. K is 5. So I'm going to solve for a. And to do that, I have to do 13 minus 10, which is 3. So I'm doing 3 squared. 3 squared is 9. Now, what some people do here is they say 9 plus 5 is 14 and divide by 14, and that is wrong on so many levels. A times 9, those are connected by multiplication. You need to subtract the 5 over to the other side before you try to divide by 9, because this is really like 9a, and we always divide last when we're solving equations. So a is negative 2. I'm going to write that back in my equation with my vertex, but with the x and the y as x and y, and this is my answer. So this has been the second half of our Chapter 2 review.